stellar black holes. Stellar black holes are the most common type of black hole out there, and they come from something spectacular. When a massive star, one much bigger than our sun, runs out of fuel, it collapses in on itself in less than a second. The outer layers explode outward in a huge blast called a supernova. What stays behind is an incredibly dense point wrapped in an invisible boundary called the event horizon, the line where nothing, not even light, can escape. From the outside, it looks like a perfect circle of pure darkness with a glowing ring of bent light around it. That ring forms because gravity is so strong, it literally curves the path of light around the black hole. Most stellar black holes are only a few dozen kilometers across, roughly the size of a city, but they contain several times the mass of our sun. They are scattered all across every galaxy, and studying them helps scientists understand what happens to matter and gravity at their absolute limits. Supermassive black holes. Supermassive black holes are a completely different scale. These sit at the center of almost every large galaxy, including our own Milky Way. Our galaxy's central black hole, called Sagittarius A star, holds about 4 million times the mass of the Sun. When these giants are actively eating gas and dust, the material around them heats up and glows so brightly that it outshines the entire galaxy. And at that point, it is called a quasar. Visually, you would see a flat spinning disk of glowing orange and white material swirling inward like a fiery whirlpool. Two enormous jets of energy shoot out from the top and bottom, stretching thousands of light years into space. The largest ones ever found are wider than our entire solar system. They control how galaxies grow, regulating when and where new stars are born, which makes them one of the most important objects in the universe. Intermediate black holes. Intermediate black holes are the ones scientists argued about for decades, because for a long time, nobody could find them. They sit in the middle, bigger than stellar black holes, but much smaller than supermassive ones, containing between a few hundred and 100,000 solar masses. The strange thing is that early observations only showed the small ones and the giant ones, with nothing in between, which made astronomers suspicious. These medium-sized black holes tend to hide inside very dense star clusters, where stars are packed so close together that collisions happen all the time. Some of them appear to drift slowly through their galaxy, rather than staying fixed in one spot, like an invisible force silently wandering through a sea of stars. Many scientists believe these are the seeds that eventually grew into the supermassive black holes we see today, slowly gaining mass over billions of years through mergers and feeding. Finding more of them is one of the most active goals in astronomy right now. Primordial black holes. Primordial black holes are unlike any other type because no star created them. They may have formed in the very first moments after the Big Bang, nearly 14 billion years ago, when the universe was so dense and chaotic that some regions collapsed directly into black holes before any stars existed. They could range in size from smaller than an atom to as massive as a mountain, or potentially much larger. A primordial black hole the size of a grain of sand could carry the mass of an entire mountain range, which tells you just how unimaginably compressed they would be. What makes them especially interesting is that they are a serious candidate for dark matter, the invisible substance that makes up about 27% of the universe, and that scientists still cannot fully explain. If they exist in large numbers, they would be drifting silently through galaxies right now, bending starlight through gravitational lensing and pulling on gas and dust in ways that look exactly like dark matter. Astronomers are hunting for them by watching for tiny flickers in starlight caused when one passes between Earth and a distant star. None have been confirmed yet, but finding one would be one of the biggest discoveries in the history of science. Rotating black holes. Rotating black holes, also called Kerr black holes, are actually the most realistic type in the universe, and they are significantly stranger than the classic version most people imagine. Almost every star spins as it burns, so when it collapses, that spin is preserved and speeds up dramatically, the same way a spinning skater speeds up when pulling their arms in. This rotation causes the black hole to drag the space around it in circles, not just pulling things inward, but actually twisting the fabric of space-time itself like a stirred liquid. This effect is called frame dragging, and it means that even empty space near the black hole gets carried along in the direction of the spin. Visually, a rotating black hole bulges slightly at its equator and is surrounded by an outer region called the ergosphere, where distorted light swirls around it in a visible halo. objects can actually enter the ergosphere and escape again, stealing a tiny bit of the black hole's rotational energy in the process. Inside, the singularity is not a point. It is a flat spinning ring, like a tiny, impossibly dense loop at the center of everything. This is the type depicted in realistic science films, and for good reason. White holes. White holes are the theoretical opposite of black holes, and they are arguably the strangest idea in all of modern physics. Where a black hole pulls everything inward and lets nothing escape, a white hole does the exact opposite, constantly pushing matter and light outward and allowing nothing to enter. Think of it like a black hole running in reverse, a one-way door that only opens from the inside. They come directly out of Einstein's equations, meaning the same mathematics that predicted black holes also allows white holes to exist. Yet nobody has ever observed one. Visually, a white hole would look nothing like the dark void of a black hole. It would appear as an intensely bright object, blazing with light and energy pouring outward in all directions, surrounded by a chaos of expelled matter being thrown into space at enormous speeds. Nothing could approach it or fall in. Any object that got too close would simply be pushed away by the constant outward flow. One of the most fascinating ideas in theoretical physics is that black holes and white holes may actually be connected through tunnels in space-time called wormholes, with matter falling into a black hole potentially emerging from a white hole somewhere else in the universe entirely. Whether they can actually exist in nature remains completely unknown, but the possibility alone is enough to make them one of the most mind-bending objects that physics has ever produced. If you watched till the end, consider subscribing my channel. That would help me a lot. Thanks.